You need to be doing. It's totally fine for you guys to collaborate because I know you're doing hard work. I have a big mouth. I can talk over you. Those of us that are not working on that fraction stuff, we are all skipping over to level 3 of that leveled work. And I'm actually going to work backwards because I know some of you guys have started and already checked the first few. So I'm going to kind of work this handout in reverse. So you don't need another copy of it, honey? You have it? Okay, will you grab it, please? So we're actually going to start with number 12. And we're going to work backwards because I know a lot of you guys have already kind of started it. So we're on the level 3 of that leveled work. I'm going to go ahead and introduce you guys to some of the more challenging ones, but with my support today. So we're over on number 12. Everybody should be on this one right here. And remember, I need the work on your paper. Since we're all over the place, I got to have that paper documented so that I can take a look at what you guys got. So the first step is the same first step that we've had for weeks. Our first step is to look and see whether or not we have any distributive property. There might not be, but we should look. That's why I'm going to write question mark. Do we have distributive property for number 12? I'm going to give you a second to think about that. Get that answer in your head. So based on that number 12, yes, ma'am. Do you have the paper copy of this, babe? Yeah. Okay. Yeah, we need that. So step 1, look for distributive property, which we had it. So now we've cleared all that out. Just be careful. Do you need me? So can you please get that paper out? You need another one? Okay. Step 2, we need to decide whether or not we can make it a little more simple. And in order to determine whether or not we can make it a little bit more simple, we need to look and see, do we have any like terms? So my question number 2, I'm going to ask myself, do I have any like terms? And I'm putting a question mark there because I don't know yet if I have them or not. My first question is, I'm just going to go ahead and tell you, I can't combine anything over there. Why not? Why can't I put anything together over there? Why can't I make that more simple? What have I got over there? Do I have 2 letters? Do I have 2 letters on the left-hand side? So can I put them together? Nope. I got a number and I got a variable. Can't combine them. However, on the right-hand side, I do have 2 variables that I can combine because they're both a V. So take a minute, use that calculator if you need to. That's what it's there for. Think about what you're going to get when you combine that -5 and that -42. You doing okay on that? Okay. So that -5 and that -42. V. What are we going to get when we combine those? So type in your calculator. The negative button, 5, subtract 42 is what's going to give you the right thing there. Remember, don't just put 2 negatives back to back. Your calculator is going to multiply. So -5 minus 42 is going to give me a -47 V. Can I combine a V and a 6? Nope. Okay, so that's all I can do over there. Now I'm going to bring down my -V plus 6. So step 1 is always, can you distribute? Step 2 is always, can I put something together to make it a little bit more simple? Step 3, we now need to see what we need to do to isolate. Okay, when you're isolated, when you're by yourself, how many of you are there? 1. Right now, we've got a variable on both sides of that equal sign. One of them is going to have to go. 2 is the opposite of being isolated because you got 2 instead of 1. You got to get by yourself if you want it to be isolated. We're right there, ma'am. So one of them is going to have to go. I can't put them together because they're not on the same side of the equal sign, okay? That's why we can't just willy-nilly like, hey, I'm just going to put those together because they're not on the same side. So one of them's going to have to go. It doesn't matter which one you get rid of. Which one's bothering us the most? Because it literally doesn't matter which one. You want to get rid of the minus 47 or you want to get rid of the minus v? The minus 47, that's what I would do too, honestly. Okay, so the opposite of a we're not going to do that, okay? If we do that, it cancels the 47, but it still leaves the v. So we still have a variable there. We don't want a variable there. So instead, we got to cancel out the whole thing. The opposite of a minus 47 is a positive 47. So after we combine those like terms, we should be canceling out one of those variables. Oh, yeah, that's right. I'm sorry. I thought I messed up for a second, but no, I didn't. Okay. I'm not going to do this because you can't put a number and a variable together, but I do need to do plus 47 on both sides. So I'm actually going to take it away from the minus v, or I'm going to add it, I guess I should say. So what number is technically in front of that negative v?
0.
There's a 1, so that's a negative 1. So you'll put in your calculator, negative 1 plus 47, and that'll tell you how many v's you have left once you combine those. So what do we got? 46, yep. 46 v's. That plus 6 has just been chilling out, waiting for his moment to do something. Over on the other side, we've canceled those out. And I still need to bring down that other 6 that's been chilling out there waiting. So we're still isolating. So now that we got it down to one variable, we got to get that one variable by itself. So what's sitting there with the v that needs to go away? What would be so we got that 46. I wouldn't deal with the 46 first, though, because remember, you got to divide everything by 46, and eek, I don't know about you, but I don't want to do 6 divided by 46. It's too early for all that. So instead, I'm going to cancel out the plus 6 first. What's the opposite of a plus 6? Minus 6. And make sure you remember to do it on both sides. So those will cancel. That's going to leave me with a 46v. And then 6 minus 6, we can't just forget about that side of the equation. We need to write a 0 there. Now let's divide both sides by 46. So we got v is equal to 0. I know those are doing the most. That is a lot of freaking steps. That's why we're taking it slow. But the steps that you need to look for are always the same. You need to see whether you need to distribute. You need to see if there's some like terms that you can put together on either side. Then you need to get that variable isolated. Same 3 steps to look for, even though it's doing a lot. Okay? I'm going to shut up for a minute, give you a chance to look at number 11. So step 1, see if you got distributive property you can do. Step 2, see if you have any like terms on the same side. Step 3, once you do all that, get that variable isolated. So get down to one variable and then get off everything else that's on that same side. I'm going to give you all a couple minutes to do that. Most of y'all noticed, which is awesome, something a little peculiar about this one, which actually saves you some work in the long run. So step 1, we noticed we got distributive property we can do. I'm so happy with you guys. Y'all killed this. So negative 6 times n is negative 6n. Negative 6 times 4 is negative 24. And we're going to bring down everything else. I can't combine those because they're on the same side, but they're not like terms. I can't combine those. Oh, oops, I wrote 64 instead of 6n. I don't know why I just did that. Sorry, y'all. Can't combine those because those aren't like terms either. But I did notice something a little peculiar. I noticed that I have negative 6n, negative 6n, paired with a negative 24 and a negative 24. The same variable paired with the same exact number means it's always going to balance out no matter what and is equal to. So remember, we've got two different ways you could write that. In 8th grade, most teachers, at least that I know, would say that has an infinite number of solutions, which means you could literally sit here all day long and plug numbers in for n. No matter what number you plug in there, it'll work. When you get to Algebra 2 here at Ballard, most of your teachers will say all real numbers. Two different ways of saying the same thing. Means that you could literally put any number in there that's real anyway. Yes, there are numbers that are not real. You'll learn about those in Algebra 2. And either way means the same thing. So if you remember what we talked about the other day, you should be, I see you, Sarah. I'll get you in 1 second. Once you do step 1, you're finished because there's literally nothing else for you to do because you should have noticed. Same variable, same number on both sides. That's an infinite number of solutions. Okay, I'm going to shut up for a minute. Turn you loose on number 10. Since we're working backwards, I'm going to be back to work it for you in a minute, but you try it out yourself first. What's step 1? Look to see if I have any what? See if I got any what? Distributive. Do I have it? Yep. Yes, I see it because it's right there. So I'm going to distribute. I'm going to do that -6 times k, which gets me -6k. -6 times -1 gives me +6. So now I'm just going to bring down the 5 because the 5's just been chilling there, not doing anything. I'm going to bring down the other side of the equation because there's no distributive property that I can do there. Step 2. Do I have anything that I can combine? So let's start on this side of the equal sign. Anything I can combine? Anything, anything, anything? No, not like terms, right? You're looking at me though. What can I combine? In what?
I was gonna ask, isn't that -6?
Great question, especially since I screw up a lot, but this time I did not. Negative times a negative would be a positive. But that's good for you to check me out because Lord knows I might have made a mistake. While we're at it, do we have anything over here we can put together? So we don't have any variables, but don't we have something else? We got numbers we can put together over there. You can 5 and 6. Those are like terms. Okay, numbers go together. You can always put numbers together. So 5 plus 6, because those are both a positive. So 5 plus 6 is 11. I'm going to bring down the -6k. We should notice something is up. How do you know it's an infinite number of solutions? Yes, exactly. So we've got now it's in a different order, but it's still the same thing. -6k, -6k. +11, +11. So we have exactly the same variables on both sides with exactly the same number. They're always going to balance out, which means that we are going to type an infinite number of solutions. It doesn't matter what number you substitute in for k. It is always going to balance out. Or you could say all real numbers, because any number that you put in there will make it balance out as well. So if you know, that's why we kind of did that little game. If you know what to look for, it can really save you a lot of work. I see you, Savannah. You'll be my next stop. Okay, I'm going to shut up for a minute. We're going to keep working backwards. Number 9. So look for that distributive property. Look and see if you can put anything together. Isolate the variable. I'll be back in just a couple minutes. First question, can we distribute? Is there? Yes, we know this answer by now. So we're going to distribute. So that'll be -42m. -7 times -5 is +35. So we got everything out of the parentheses. That 8m has just been chilling out, or -8m, I should say, has just been chilling. So we're going to bring it down. Okay. And then over here on the other side, I have -8m plus 35, because there's no distributive to do there. Most of you guys noticed I have like terms that I can put here. Put in your calculator -8 subtract 42 in order to get the right thing. You're going to see you're combining two negatives together. So that's negative, oh, not negative 40, negative 50, my bad. Negative 50m. If you combine those, I'm going to bring down the plus 35. So this is where I see some of you guys kind of getting stuck. Did I make a mistake somewhere?
Isn't when two negatives equals a plus?
Not when you're adding and subtracting. That's a great question. And we can prove it. If you type in your calculator, put the negative button, 8 minus 42, you'll see it'll tell you it's negative 50. Two negatives make a positive when you're adding and subtracting. But when you're multiplying, when you're multiplying and dividing, two negatives make a positive, but not when you're adding them together. So this isn't special because I don't have the same variables on both sides. So now that we have distributed, put our like terms together, we got to choose a variable to disappear. Which one do you want to get rid of? Because it doesn't matter. You want to get rid of minus 50m or minus 8m? Okay, let's get rid of minus 8m. He spoke up first. We get rid of a minus 8m with a plus 8m. If you divide, you're going to get rid of the 8, but you're going to leave the m behind. You don't want to do that. You want to get rid of that entire thing. So on this side, that's going to cancel. You're going to bring down that 35. Negative 50m plus 8 is negative 42m. If you put in your calculator negative 50 plus 8, you'll see you'll get negative 42. And bring down that plus 35. So the m still needs to be isolated. It's going to be easier to get rid of that plus 35 first. How do I get rid of a plus 35 minus 35? And do it to the other side as well. You can't just forget about this side of the equal sign. They technically cancel each other out, but you need a 0 there. Don't just say, I'm done. There's nothing over there. And bring down the negative 42m. How do you cancel out the negative 42? This is old news. Divide. Yes. Old news. So 0 divided by 42 gets you m is equal to 0. I know these are doing the most. Y'all are really doing a good job handling it. I'm going to shut up for a minute. I'm going to leave this in case anybody is still looking at number 9. I'm going to work number 8 for the group in a minute, but I want you to try to work it out yourself first. All right, do I have distributive property? Yes, I do. So I'm going to distribute 4a minus 6. I'm going to bring down that negative 10 plus 4a. I should stop in my tracks because what do I have here? I have the same variable. Do they have the same number on either side? They do not, right? We got the same variables, but that one's got a negative 6. That one's got a negative 10. That can't balance out. You can't have 4a's minus 10 be equal to 4a's minus 6. That's just impossible. So this is where we should stop. You should really only do that one step to get new solution. All right. So everybody, no matter what you're working on, I'm going to go ahead and take like what you've got at this point. My fraction people, you know I know that fraction stuff was hard, okay?